students. Welcome to a new week. My name is David Olemo. I'm the mathematics instructor for White Knight Academy, Barangoni, FCT Abuja. Today, we're going to be going a step further by considering the topic Pythagoras rule. Pythagoras rule. And the lesson objective for today is the fact that we should be able to state Pythagoras rule, and then you should be able to find the sides of a right angle triangle using the Pythagoras rule. And then the third thing you're expected to be able to do is to be able to apply Pythagoras rule to solve some more complex questions. Alright, let's get straight to work. Pythagoras rule is actually for right angle triangles. And if you look at the right angle triangle that we have here, you can see that there are three sides. You have this an adjacent side, and this is also another adjacent side. And then we have the third side, which is called the hypotenuse. So we label it A, B, and C. So side A and side B, they are adjacent to one another. They are adjacent to one another. While side C is called the hypotenuse, which is the longest side of the triangle. Now, Pythagoras rule states that a squared plus b squared is equal to c squared. I repeat, a squared plus b squared is equal to c squared. Alright, there's an example here to further understand Pythagoras rule. Alright, now in this diagram here, we have three triangles actually. We have to calculate the line segment AD in this diagram. So we have AD. But if you can see clearly, you can see that we have two right angle triangles there. So we have triangles ABC. We have triangles ABC. Triangle ABC and triangle DBC. Those are the two right angle triangles there. The third triangle there is triangle ADC, which is not a right angle triangle, it's a scaling triangle. But we have two right angle triangles. So we have triangle DC, which is a right angle triangle, another right angle triangle AB. So now, looking at this side, you have side AB. We discover that AB is made up of AD plus DB. And at the end of the day, we're going to have side AD to be equal to AB minus DB. AB, side AB, length AB minus length DB will give you length AD. Okay, in triangle ABC, right angle triangle ABC, as usual, using Pythagoras rule, we have AB squared plus BC squared is equal to AC squared. Yeah. So AB squared plus BC squared is equal to AC squared. And that is Pythagoras rule. The sum of the square of the two adjacent sides of a right angle triangle is equal to the square of the hypotenuse. Okay, so length AB, we don't know it, but we know length BC as 4 units. And so we substitute 4 in place of BC, and then AC is 6 units. So that means that AB squared plus 4 squared is equal to 6 squared. Go a step further, we bring 4 squared to the other side. We call it collect like terms. So that means that AB squared will be equal to 6 squared minus 4 squared. And then, to evaluate, 6 squared is 36, 4 squared is 16. So that means that AB squared will be equal to 36 minus 16, which is equal to 20. And since we are looking for side AB in this Pythagoras rule, we take the square root of both sides, and automatically AB will be equal to square root of 20. Okay. Then we go to triangle DBC, right angle triangle DBC. We're going to be using Pythagoras rule for that. And in right angle triangle DBC, DB squared plus BC squared is equal to DC squared. Okay, so we have it here. You have db squared plus bc squared is equal to dc squared. So the sum of the square of these two adjacent sides of this right angle triangle is equal to the square of the hypotenuse. The hypotenuse is BC. DB and BC are the adjacent sides. Okay, so the values, side BC is 4 units, while side DC is 5 units. So DC is 5 units, BC is 4 units, but we don't know DB. And therefore, we substitute. Therefore, we have DB squared plus 4 squared is equal to 5 squared. And then DB squared is equal to 5 squared minus 4 squared, collecting like terms. 5 squared is 25, 4 squared is 16. Therefore, DB squared is equal to 25 minus 16, which is equal to 9. And you take the square root of both sides. DB will now be equal to square root of 9, which is equal to 3. The square root of 9 is 3 units. Therefore, DB is equal to 3 units. And since we are looking for line segment AD, we are looking for the length of line segment AD. And from the first formula that we have, that AD is equal to AB minus DB. So we're going to substitute AB and DB and find their difference. All right. So the value of AB is root 20, square root of 20, and the value of DB is 3. Therefore, line segment AD will be equal to root 20 minus 3. When you press your calculator to find the square root of 20, to give you 4.472 to 3 decimal places. So you have 4.472 minus 3. And then that will be equal to 1.472, which is approximately 1.5 to 1 decimal place. That means that the length of the line segment AD is approximately 1.5 units to 1 decimal place. Right. The second example about Pythagoras rule, the question says is a word problem. The sides of a rhombus are 17 centimeters long. If one diagonal is 30 centimeters long, what is the length of the other diagonal? So this is a diagram showing, so we have rhombus ABCD. Rhombus ABCD. Alright. Okay. Now, AD is 17 centimeters. Sorry, it wasn't included. AD, AB, BC, and CD, they are 17 centimeters each. Okay. And then we're told that one diagonal is 30 meters long. BD is a diagonal. AC is another diagonal. BD is 30 centimeters long. We are asked to find the length of the other diagonal. So if BD is 30 centimeters, OD, which is half, which will be half of BD, will be 15 centimeters. We divide into 2 equal parts. The diagonals, they bisect each other. They cut each other into 2 equal parts. So in triangle AOD, we have, so this rhombus is made up of 4 right angle triangles. Looking at the diagonals, the diagonals divided into 4 right angle triangles. So in right angle triangle AOD, we use Pythagoras rule. That will be AO squared plus OD squared is equal to AD squared. AO squared plus OD squared is equal to AD squared. And then we substitute AO squared plus 15 because our OD is 15 units. So AO squared plus 15 squared is equal to 17 squared. Then we collect like terms, we bring 15 squared to the other side. Therefore, AO squared is equal to 17 squared minus 15 squared. And then AO squared will be equal to 17 minus 15, 17 plus 15. Open bracket, 17 minus 15, close bracket. Open bracket, 17 plus 15, close bracket. And this is what we call difference of 2 squared. Instead of writing the square of 17, which is 289, and the square of 15, which is 225, we decided to use this method. They call it difference of 2 squared. Difference of 2 squared. And so it's an identity in algebra. Okay. AO squared is equal to 17 minus 15 is 2, and 17 plus 15 is 32. When you multiply 2 by 32, it gives you 64. And then you have to take the square root of both sides. The square root of AO squared will be equal to square root of 64. And therefore, AO will be equal to 8 centimeters. That is length AO. But since we are asked to find the length of the other diagonal, the AO that we got is actually half of AC. It's half of AC. AO will be half of AC. AC is the other diagonal, and Diagonal VD bisects AC into two equal parts, AO and OC. So we got the value of AO as 8 centimeters. Therefore, this will be 8. Then OC will also be 8 centimeters. When you add it together, it gives you 16. Or multiply it by 2. So we said AC, line segment AC is equal to 2 times AO, which is equal to 2 times 8. And then AC will be equal to 16 centimeters. So that is the length of the other diagonal of the rhombus. I believe you understand these two examples that we've treated with you. Go over it once again, and then you have 2 questions relating to the examples that were given. So you have exercise 1 here. You have a right angle triangle, 2 right angle triangles here, just similar to the first example. And so you're going to be using Pythagoras rule for this first right angle triangle here, and then for the second one. And so you have to find the values of x and the value of y. What is x? What is y? And then the second one also talks about rhombus. The diagonals of a rhombus measure 8 centimeters and 6 centimeters. It is the diagonals they gave us now. They gave us the dimension of the diagonals. We are asked to find the length of the side of the rhombus. Well, there's a hint I will give you. You know, the 2 diagonals, they will bisect each other. So that means that in a right angle triangle, one of the right angle triangles will have one of the sides will be 4 and one of the other side will be 3. And then from there you use Pythagoras rule to determine the hypotenuse. I believe you understand today's lesson. We have come to the end of today's lesson. Once again, my name remains David Olemo. Have a wonderful week.